Hi there, welcome to Stat 200. I'm your instructor Dan Spencer, and here I have to present to you the very first office hours, lesson 1 office hours. Now, this lesson we're just kind of getting started. There's not too much in terms of math involved. It's more of a thinking lesson. One of the important things we're going to talk about are different sampling methods. Simple random sample, for example, stratified sample, cluster sampling, systematic sampling, etc. So let's get started. These are some of the problems that I've given my students the most trouble in the past on their unit quizzes. So let's take a look at these, and I'll also do some further explanation, especially for the difference between a stratified sample and a cluster sample. That tends to throw people for a loop. Alright, first question. Which of the following is the best example of a population from which a cluster sample would be easier to obtain than a simple random sample? That should say than, not that. Right there. No big deal. Alright. So, first off, let's talk about the distinction between a cluster sample and a simple random sample. A simple random sample, you have your population. Let's say your population is everyone in this box. There are lots of little people. They're all over the place. So what's a simple random sample? A simple random sample says, oh, you know what? I'm just going to go through. I'm going to look at all these people, and then I'll just pick them out at random. So I'm going to pick this dude, and I'll get this guy, and this one, and this one, and this one, and this one. You know, just kind of at random. It's a simple random sample. It's just randomly chosen, right? Now, a cluster sample is a little bit different. A cluster sample is really useful if you have a population, let's say it's a similar population, but now let's say that all these things that I'm sampling, let's take it away from people. Let's say, I don't know, this is like a drawer that you pull out of your desk and it's only full of different types of screws, and you want to get a good idea of the types of screws you have. So you might do a simple random sample by doing it this way. You might just say, okay, well, there's just a ton of screws here. I'm going to pick however many, 8 at random, and then I'm going to say that's pretty representative of what's going on in that drawer. Now let's say we open the drawer, and instead of the drawer just being one giant drawer, it's got several compartments. And in a cluster sample, or why you would use a cluster sample, is if each of those compartments you think is pretty much representative of the population, meaning the mix of nuts and bolts and whatever I was saying, screws is actually the example I was using. The mix of screws is the same in all of these little categories, in all of these drawer compartments. They're all the same. They have a homogeneous mixture, if you're scientifically inclined. So in a cluster sample, what do? Well, now you're not going to just go willy-nilly choosing different screws from all over the drawer. In a cluster sample, what you're going to do is you're going to say, okay, well, let's just look at this drawer, and I don't know, maybe I want to increase the power of my test, so I'm going to do another cluster sample. I'm going to look at that drawer. So I'm only going to look at those two drawers, assuming that these clusters are more or less representative, right? So in a cluster sample, I'm not going to get anything from these, but that's okay, because I'm assuming that everything that's in these two boxes is representative of the entire drawer, right? The mix is the same. So thinking of that, what we have to keep in mind is when we're looking at a cluster sample, we want to have the ability for our population to be broken into discrete chunks, separate chunks from each other, but in each of those little chunks, the units that are inside are representative of the entire population. Okay? In a simple random sample, I mean, it's really much more simple, obviously. You know, you just have everything in one big bin and you're just pulling out of that bin randomly. So let's apply that to what we see here in this question. We have 4 options. So we have passengers who will be flying in the upcoming week on a certain airline. We have registered drivers in a certain state. We have employees of a large company. And we have members of a national organization. Now, this is kind of a subjective question, sure. But just think about which one of these is probably the easiest in which we can create these little tiny bins, these little clusters that are going to be more or less representative of your population as a whole. Well, members of a national organization, that's going to be tricky because you might be able to break it down by area. So say you break it down by state, but then each state might be different. The population in Texas is not representative of the population in California, right? I mean, there's just a geographic effect of opinion, right? You have red states, you have blue states, you have all kinds of things that are spatially related, right? So this one's going to be kind of tricky. You'd have to think of something really specific to do that. Let's just say that one's probably not it, yeah? Employees of a large company. Very similarly, you may be tempted to say, well, I'll just break the company into its respective departments. We have the engineering department, we have the PR department, we have all these different departments, right? But if you go ahead and just pick a department, if you just pick the engineering department and you sample those people, I mean, depending on what you're sampling, they're not going to be representative of people who are in HR, right? People who study engineering and science and all that stuff aren't necessarily interested in the same things that people who do PR are interested in. So you can't really say that they're representative. They're not a good mix of everybody. Registered drivers in a certain state, that's kind of a complicated one. How would you cluster, right? How could you cluster? You could cluster by county, but we have the same problems that we had before. Some counties are wealthier, some are less wealthy, some are urban, some are rural. It's just not the same. It's not good. And that brings us to what is the best choice out of these four. These are passengers who will be flying in the upcoming week on a certain airline, right? Now that you might think like, oh, well, that's not good because, maybe, all the people who are flying to Florida are going to be different from all the people who are flying to Alaska. And maybe that's true. And in that case, it's a good idea for you to take multiple clusters, right? But in an airport, you've got people mixing from all over the place, right? So you could be having you could be sampling a flight that's going from, I don't know, Atlanta to Chicago. That's a pretty strong route in the United States. There are a lot of people there. People are there for their connecting flights. They're not necessarily coming from or going to the same place. And how do you make your clusters? What are your clusters? Your clusters are just your flights, right? Everybody who gets on one of those planes is inside one specific cluster. They're all brought together. They're easy to sample. You've got them all in a small area. You can ask them all a question really easily. And so that is why the best answer here is answer A, passengers who will be flying in the upcoming week on a certain airline. Make some clusters based on a few flights, and then you sample randomly within those clusters, right? I want to be clear that we don't sample all of the clusters, because what happens if you sample all the clusters? That's what kind of sampling? That's actually stratified sampling. We'll talk about that more later. Let's move on to the second question. A television news program asks viewers to log onto their website and vote on a different issue each day. The website allows visitors to select one of two choices and submit a vote. The results of the poll are reported the next day on the news program. The population to which the results of these polls can be extended is who? Okay, well, they're just asking viewers to log on the website and vote, right? Seems pretty good. But not everybody who's watching the news program is going to go online and go to this website, right? In fact, this is a typical problem with these types of polls. The people who are going to vote are usually the people who care the most about the issue at hand. The average person, if it's an issue they don't really care about, they're not going to be particularly motivated to take the time out of their day, log online, go to their website, spend a few minutes filling out this poll, or even might be a second, but you have to go to that website, right? It's effort. It's something you have to do. So you definitely can't apply it to, whoa, I'm moving everything. You definitely can't apply it to all viewers of the news program, right? Because like I said before, not all viewers are going to sign on. Again, you can't apply it to all visitors to the website even, because people who vote on the website are not necessarily there because they want to vote on the polls, and they may not even know about it. It says that they advertise it on the news, so they may not even advertise it on the website. It might be one of those little tiny polls that's in the bottom right and you have to go find. All viewers who have voted in any of the polls, again, this actually kind of goes along with what I was saying before. So if they have different topics each day for the polls, well, the people who care the most about that particular topic on that day are going to vote in that specific poll. But if one day you're asking about, you have a poll about, say, political ideology, and the next day you have a poll about, I don't know, animal control policy, something like that. Not everybody who's interested in political ideology or wants to share their political ideology is going to be super excited about animal control policy, right? Some people will, but not everybody. So you can't take the viewers from any of the polls. You can't just say that whatever my results are from that specific poll, they apply to everyone who has ever voted in a poll. Because the polls are different, so they're attracting different people. So therefore, the best answer here, only viewers who voted in that specific poll, right? And these types of polls are done a lot. And they're done a lot because they're very cheap and easy and quick to do. However, they're not very valid because they only apply to a very small group of people. Let me know if you have any more questions on that one. Next question. A magazine printed a survey in its monthly issue and asked readers to fill it out and send it in. Over 1,000 readers did so. This type of sample is called a what? All right, well, it's not a cluster sample, right? How did they cluster? They didn't cluster anything. They didn't group anybody. No, that didn't happen. Similarly with stratified sample, they didn't separate into strata. They just had all the subscribers, all the people who read that magazine were able to send this in. Is it a simple random sample? Close, maybe, but the thing is they're not randomly choosing people, right? In fact, people are choosing themselves. People are saying, oh yeah, sure, I like filling out surveys, and maybe they're going to give me a prize or something. And I have the extra 5 minutes today, why don't I do it? So it's a self-selected sample because the people, the participants who are giving the results, the answers in the survey, are themselves self-selected. They're saying, I'm going to do this poll. I want to do this poll. In a simple random sample, the person who's conducting the poll would approach you and say, hey, I have a poll. I would like you to participate, etc. So this one is a self-selected sample because only people, like I said before, people who have time and people who care about the survey topic or whatever are going to be the people who respond. Let's move on. Olivia wants to learn a foreign language. To get an idea of how satisfied other students were after taking a foreign language course, she decides to take a random sample of 20 students. If Olivia randomly selects 20 students among all students taking a foreign language class that year, the sampling method is a what? Okay. So Olivia's got all students taking a foreign language class, right? All students taking a foreign language class are now in this room. And here they all are. They're all just kind of bopping around, speaking foreign languages to each other in this big room. This is how Olivia is going to select them. She goes into this room and she says, okay, at random, I'm going to talk to you, and she selects 20 people this way, right? She just goes ahead and finds 20 people at random and then asks them, what is this? Is she grouping it at all? No. So it's definitely not a cluster sample. It's definitely not a stratified random sample. What's the difference between a simple random sample and a systematic sample? A systematic sample would be something like Olivia goes into the room, she has everybody line up by height, and then she selects every fifth person. So she starts with the fifth person, then selects the 10th person, then the 15th person, and so on, right? That would be a systematic sample. But here it just says she randomly selects 20 students from all the students. She doesn't say that, she's only going to select the third person she meets, anything like that. She just says she's going to select 20 students at random. So what's that? That is, I think pretty clearly, a simple random sample. All right, let's move on. There are 5 cities in a politician's district, but redistricting has been proposed for the state. The politician would like to know which city he should try to remove from his district. He plans to conduct a survey to find out his approval rating. Which one of the following sampling plans would be most useful for his purposes? Okay, so we've got a few options here. We've got 2 ideas for taking a stratified sample. 1, 2. We've got a simple random sample, and we've got a cluster sample. Well, he's trying to find out which district he wants to remove. So let's just think about his district, right? His district, let's say his district has 4 cities. And maybe he's really well liked here. They like him a lot in this district. They're like okay about him here. They like him a lot here too. But in this district, they just do not like this guy at all. Right? Let's say that that's how it actually is. And he wants to know which of these 4 cities should he drop out of his district. Now, what's he trying to do? He's trying to get reelected, basically, right? So he wants to knock out the city, take that city out of his district, take the city that likes him the least out of his district. That way he, is the politician for a district that really likes him, and he's going to get reelected, and as a politician, that's great because he likes job security. So now we need to think about each of these. Now inside each of these districts, each of these cities inside his district, there are lots of people just living their lives. And what's he going to do? Now, if he takes a stratified sample with political parties as the strata, would that be useful? I mean, he would basically find out how many people in his political party like him, right? And how many people in the opposing political party like him. And that's not really what he's trying to do. He's not trying to, do some kind of strange redistricting where he only gets people who are his political party. That wouldn't help him. B, take a stratified sample with 5 cities as a strata. Oh, okay, so he has 5 cities. It does say 5 cities. Apparently I can't read very well. Assume that these are 5 blocks. And it says, take a stratified sample with 5 cities as a strata. So each city is its own little strata. And then, remember, in stratified sampling, you're going to sample actually from each and every group. So he'll take a sample from here, he'll take a sample from here, sample from here, and a sample from here. And he'll try to take equal numbers from all those places. So he might take, 100 people from this city, 100 from here, 100 from here, 100 from here. And then he polls them, and he sees how many of those people approve of him, right? So this is actually going to be what he wants to do. He wants to take a stratified sample. Because if he does this, he's going to find, oh, hey, man, this city likes me. This city likes me a lot, too. This one's not so sure, but this one's super doesn't like me. They want me gone. So if I want to do a redistricting move, what I want to do is I want to get rid of this city. I want him out of my district, because if that city is still in my district, that's going to bring my approval rating down. It's bringing my likelihood of getting reelected down. I definitely don't want that. So this is what he's going to do. Let's talk about how that's different from these other two. So, take a simple random sample across his district. It's like what I was talking about before. He'll just like randomly select people from all over the district, and then he's just going to combine all those results. He won't have any information about his, about which city is liking him more or not. He'll just say, oh, this person liked me, this person didn't like me, this person liked me, this person liked me, this person didn't like me, this person liked me, etc. So he's not going to know, right? So a simple random sample it's not going to give him the information he wants. He doesn't just want to know how people feel about him. He wants to know where the people are and how they feel about him. Which brings me to the last one, a cluster sample. Now this is the trick one, right? Because here's a cluster sample with 5 cities as clusters. Here's a stratified sample with 5 cities as strata. What's the difference? I've had a bunch of questions about this on the homework and previous semesters. I see this one all the time. The distinction between a stratified sample and a cluster sample is that in a stratified sample, you sample from every group. From every subgroup in here, you're going to sample. So you're going to take a sample from all 4 cities here in my diagram. But a cluster sample, what a cluster sample does, is it breaks things up into the same groups, or maybe not the same groups, but it breaks your population up into groups again, but then you only choose a few. You don't choose all of the clusters. So if he decided to do cluster sampling, he might select this cluster and this cluster, and then he would only perform simple random sampling within these 2 cities, completely ignoring these 2 cities, right? So that's the difference. In a cluster sample, you want your clusters, you want your groups to be more or less representative of the population, and you're only going to take a few of those groups and sample within them. With a stratified sample, you're going to break your population into groups. Usually they are groups that you think are important. Grouping by city, grouping by age, grouping by political ideology, grouping by some factor that you think is going to have a critical part to play. Or it's going to give you information you want. Like he wants to know about how people feel about him in each city. So in this case, he's going to take a stratified sample because he wants to know in each city how people feel about him. Okay? So that's probably the hardest part of this first lesson, is the distinction between cluster samples and stratified samples. Stratified sample, you sample from every group. Cluster sample, you don't. And in cluster sample, you want your groups to be more or less representative of the population. Okay? Let me know if you guys have any questions on that. Welcome to Stat 200. Once again, I'm your teacher. I'll talk to you guys soon.